tuần.
Trước cũng cái video mình gửi cái này cũng gửi sao?
Xem cái phần mềm xong rồi thao tác trên đấy. Cái quan trọng nhất là check lại cái biểu đồ ấy xem là nó có đọc đúng từ điện tử sang cái data như
Yep, it's got a solution. So 250. Yeah. So currently now it start to wet in the nanopore. So because we previously added the solution below the nanopore and up the nanopore. So the nanopore you see here already got some value, which means that it's already wetted, but it's accounted for like a 350 seconds. Basically, we don't need to wait for that long. Once the nanopore have established a stable baseline, which means it's stable, because this software is just like guided mode, so it show you it need to take that long. If you go to the advanced mode, so we don't need to wait for such a long time. So you see that it's used the maximum system pressure to pushing the liquid to the nanopore, and then let's say passing the hole. And then as you can see when I touch it, so it have signals. So because like the electric signal will affect, you will just in the case down. So that one still cannot turn on. Yeah. Still cannot turn on that one.
No, not turn on.
Yeah, we just shorten this time. We don't need to wait for this second. We can just start. And once nanopore is set up, we click Start Analyze. And then increase the voltage to around 500. And then put this to, you need to be 600. Oh, sorry. 700. We need to let the current like above like 100. Between 100 and 140 nanoamps. So in this one, we will do a size and concentration measurements. We will include the calibration particles. So calibration particles, we just use the TKP200. And there's a bottle set that for these particles, you see the mean size is 215. And the raw concentration is 1.011, and the dilution is 51 times. And we click done, and then we need to replace the liquid with the TKB200. So do we have any paper? Just on the cream.
Với không bụi hả em?
Ái suất mình lo cái gì chị Huyền?
And then put the TKP calibration particles on it. It's just like 35 microliters. And
TKB
then
200.
put it down to the bottom, release. You see already particles there. We'll put on the shading cake. This is to avoid the outside signals such as mobile phone to affect the system. And then stick here. And then we've just followed the step. It's guided mode. So yeah, it contains the particles. And then we will set middle pressure. So it's around 400. Usually we use 400. And then we click Start Analyze. So the system is recording the calibration particle date.
Yeah.
So it's under 3 different pressures. This one procedure is automatic, so you just sit and wait there.
How long is it finished?
For the calibration, but you can see the particle rate, it should take like around 5 minutes for the calibration particle, because we said that usually you can use like three pressure calibration is the most accurate. Usually for a quick screen you can just use 2 pressure because the three pressure is to make sure it's form a linear relationship.
Yeah.
Like, basically 2 pressure is already linear. 3 pressure is to make sure the third point fall into the linear one.
Yeah.
And because like we use this is a changing particle, the concentration is slightly lower, so that's why it takes a slightly longer time. But you see here, so the actual calibration particles is highly concentrated. This is 13, so the running speed is slightly higher than that one. Basically, as I said, each one is a particle detector. You can see from here, and also you notice like there is already particle count here, and this one indicates the system noise. It's automatically, because previously we set a medium pressure, so that's why we set the medium one is 400 PA, and then the system will automatically do minus 200 and plus 400 by itself. So we only need to set the medium one. This is not to say that you have to set it at 400. You can choose any pressure you like, but you just need to let the rate fall in between like 200 to like 1,500 or 2,000 for the calibration particles. This is to maintain the accuracy of the calibration particles.
Yeah. But if the data in that means if there are the mistakes in the reading compared to the standard speed, how we calibrate the machine will automatically calibrate.
Yeah, because the system is running the calibration and the sample at the same parameter, like the voltage, the stretcher, the pressure. So the calibration data system will use the calibration data to form a linear strip because it's linear. And then when you do your samples, later we do the analyze, so use the calibration linear strip to find the correct value for your samples. Basically, the size is little different. For the concentration is linear. For the size is like to the power of 3 because it's cubic, right?
Yeah.
So that it's like it's not linear. It's like curve, but it's also following the mathematical formulations. So by using that way, it's calculated the size concentrations.
Yeah.
And for the zeta potential, it's linear shape.
Yeah.
So we calculated the linear shape of the calibration particles and then added the things. Currently, you see that we didn't do any troubleshooting, but I need to say that there is a troubleshooting is needed when they are very large particles, because you see the calibration particles is certified at a very narrow range, and sometimes for the UV, you cross from, for example, from 50 to 400. So the nanopore pole size is certain size, for example, is around 400. So your large particles may block the nanopore. In the event, the baseline will drop a lot. So that one you may this is a PAD called a pressure application device. There are 2 sides. So this side is to manually give the system you tap on the nozzle because it's metal, so it's will not harm for the system. Give it instant pressure, and then to let the very large particle passing through the nanopore. But you may doubt, this affects the reading. No, the system has calculated, because when you calibration already done. Okay. If you're tapping it, you see there's a trend up and down. Yeah. So system will delay that date for your troubleshooting. And also there's a chance for the large particles totally block the nanopore. So the current will drop to a lot, maybe drop to 0. So in that case, you see these 2 sides of this pressure application device. We use the plunger side to give instant pressure. It's also to encourage the block the nanopore to particles to force it passing through. And then what's your intervention? You see is different to the normal running particles. So the system will remove that date, it won't affect your readings. And you see that this is calibration has done, so just take around 5 minutes. And then this is the QC map. We know that with the higher pressure, the flow rate should be higher. So it's linear.
Yeah.
That's why we read 3 pressure reading. If we want to have too many samples, for example, like 20, 30 samples a day, to save time, you just need to do 2 pressure. It's fine to save time, because the third one, just to confirm it's right. And you see with the higher pressure, the flow rate is higher. So which means calibration has done. So we click OK. Oh, sorry. This step, it will ask you to watch the nanopore. I need to take that out, sorry. So you see, when you accidentally put it out, it will report error. So it doesn't matter, because I escaped 1 step. I just need to remove the particles. Usually we use skim wipes, but we don't have to. Just use this one. Totally fine.